we go. There, got the weapon entirely free. Maybe not the best design of how to get a motor on there, but you know it works. Alright, so now let's pull the stator off and see what's going on. Let's see if you guys can you guys see that? Try and focus it in a little bit more. Looks like it's most burnt on this side. I can't really tell what happened. I don't think it doesn't look like a piece of metal or anything got in there. Or, oh, wait. I'm gonna cut this piece off. No, I guess that wasn't the thing either. I thought that these were tied down with and they were kind of like all squished together. And I thought maybe they had some sort of a short going on in there, but I don't see anything going on there. Yeah, I really don't know. Perhaps, I mean, this was the first competition that I ran at 3-cell LiPo instead of a 2-cell LiPo. Perhaps it was that. There's too many amps flowing through. I mean, this motor was rated for up to 4 cells, I think it was, but anyways, yeah, so I guess while I'm here, I'll just show you how I have my weapon motor set up. Or my weapon set up. I've gotten lots of questions actually from other competitions, or from all the different competitions, on how I actually have my weapon worked. So this here is the body of it. It's just a solid block of aluminum that I milled out, or I put on a lathe to make it as circular as possible, and I lathed out these holes. It took forever to get all the sizes exactly right. You have to go really, really slow whenever you're doing it by hand, because if you go too far, then you're screwed and you have to start all over again with some other piece of metal. So you have to go really, really slow and pretty much do a little bit, measure a little bit, try it. If it doesn't fit, then keep going just a little bit more, and eventually it gets to the right size. This part right here is the magnets. These are the magnets that actually came on the original motor. I hacked the motor. I mean, that just goes in like that. I hacked the original motor. Was a Hobby King motor, a Turnigy 3530. I just kind of chopped off all I chopped off all the other stuff around on the outside casing, just so that I would have the magnets in the casing. And I put this piece of rubber that I found in a printer to just wrap it around the outside and put it in here. Helps to shock mount it a little bit, so that it doesn't get too much force whenever there's a big hit on the actual magnets themselves. And and then I put epoxy on the magnets to make sure that they would stay in place a little bit better. The epoxy that they put, you guys couldn't see that. So yeah, there's epoxy all on the inside of here that makes it so that they don't break as easily. The epoxy that they put on in the factory is usually not enough, especially with those cheap Chinese motors that you get at Hobby King. But you know, it's cheap, so what can you do? Then these teeth, they're just let me see if I can find the box. Tell you exactly what they are. Well, anyways, they're just like they're countersink hex bolts, and they seem to work out pretty well. I just replace them about every competition. They start to get a little bit beat up, but they hold up pretty well. So I put right. I had talked about I put it on the lathe, and then I put it on a mill. I competed actually with the whole thing being circular once or twice. I don't remember how many, but it ended up just being like I had too much weight in my weapon, and I couldn't. Couldn't put enough actual weight into my drive system, and so I would just keep getting my wheels blown off and stuff like that. And so yeah, I ended up putting it into a mill to just sort of chop off these two ends, and it makes it sort of like almost like a cross between a beater and a drum. But it seemed to work out pretty well. So here's the other piece. Here's the stator from the motor that I had. I have it. I had to modify it. I bored out the center to be 3/8 inch. It was smaller than that before, and then I put a pin through here, through the shaft, and through the stator to keep it on. And I attached my own wires onto the stator so that they would be long enough to go all the way out of the motor and into the robot. Here's an interesting piece that took me a while to think of how to have it work. So in order for this sort of a design to work, you have to actually have the motors or the wires to the motor come out of the weapon and into the robot. And there's a couple different ways that people have done this. One way I've seen is that they have a big enough shaft that they can just bore a hole into the shaft, and it's a hollow shaft, and they can just have the wires run straight out through the shaft. And I've seen that work well before. Now, but with my situation, my robot's too small, and the shaft is too small of a diameter. I couldn't have a hollow shaft and have the wires be able to fit through there and come out, and still have a strong shaft at the same time. So what I did is instead I made a custom little piece that would fit into the end of the bearing, and you can see that there's this hole right here, and this stays still. This can stay still while the weapon is turning, and the motor and the wires just kind of come out through this little hole, and they run down. You can sort of see I have a little groove on my side piece for the wires to come down out of the weapon and into the robot to connect to the speed controller. So yeah, that's pretty much what it is in a nutshell. Kind of sad I didn't really find anything more definitive. Maybe it was my first thought was, like I had said, was with this piece rubbing up against the stator. I just didn't leave enough space, and eventually it just wore off the enamel, that would make sense, I guess. That's the only thing that I can really think of what would happen besides there just being too much current drawn through it and then they just burnt up. But anyways, that's my robot. Now he's all taken apart. Oh, I wanted to show you what insides I'm using. My motors are the 1000 RPM motors that you can get off eBay, or I suggest getting them from kitbot.com. Apparently there are some batches of these 1000 RPM motors that are not quite as good as the other ones, and he knows how to determine the difference between those. And he only sells the good ones on his website. He'll sell them to you battle hardened, which means that he pretty much just Loctites all of these screws that are in the gear head, because sometimes these motors are susceptible to just the gear head coming off of the motor, where the faceplate connects to the motor. Anyway, so yeah, those 1000 RPM motors, they seem to work out really well for me. They're a little bit heavier than the B16s, but that's okay. I was able to finally get enough weight to put some bigger motors in there. These speed controllers are for the motors. These are the Robot Power Wasps. They have yet to fail me. I've only bought 2, don't have any spares, but they have yet to fail me. So they have worked out really great for me. This is the Turnigy Car 35, which is my weapon speed controller. I took the fan off the top, and I shortened some of the wires and things. Took the yeah. And so then this speed controller's worked out really well for me. It's a reversible speed controller, so it allows me to run my weapon either forward or reverse depending on which way I am. My robot's completely invertible. You can drive it upside down or right side up, and it works completely the same, or it works exactly the same either way. Then this is one of the orange receivers from Hobby King. Super small, able to fit it pretty much anywhere in your robot, and I really like it. It's really cool. I haven't had it fail on me yet either. Let's see, what else? That is all I can think of. If you have any questions, just leave it in the comments. If you like this video, subscribe. Maybe I'll put some other ones up. I am working on trying to get I'm redesigning it pretty much, redesigning my robot so that he can. We're going to try and I've been learning Autodesk Inventor so that I can make it more automated, to be able to give it to people or do it myself, put it on 3D or computer-aided machines, CNC mills or things like that. Because it's really annoying. I know sometimes it's pretty annoying making a robot and then it breaks the first competition that you build it. If you can do it, if you can design your robot in CAD software, then you can design it, have fun with the design process, but then actually have it be able to be rebuilt in a very short amount of time. Yeah, so that's it. Thanks for watching.